all, welcome to Anil Nair classes. Today in this session, we are going to discuss perfect squares and perfect cubes, session 2. Already session 1, close to about 90 minutes of session, which we have taken, covering all the various important key points related to perfect squares. I will again start with the important key points on perfect squares. The first class was very fundamentals, very basics. Now in this class, I am going to take you to a very advanced level. By the end of the session, you will be able to solve most of the advanced level questions on perfect squares, possibly in the least possible time that you can imagine. Now straight away get into the class, perfect squares and perfect cubes. Now those of you, right, who are new to this class, kindly make a note of these important key points. My methods will work only if you work. Kindly take down a notebook and a pen. Whenever I am solving a problem, I suggest each and every student to solve it along with me each and every step. Most of my methods are unconventional methods. Most of my concepts you will not find it in the regular textbook or any of the YouTube live classes that you are watching or in any of the coaching centers on which you have invested so much money. Most of the concepts will be relatively new to you. I will take a very simple line, but I will solve some of the complicated problems to these simple lines. At the end of this session, you will be able to eliminate the use of pen or a pencil. I will make you utilize the fullest power of your brain. In case if you got any doubts at the end of the session, kindly feel free to mail us at support@anilnairclasses.com. Do not miss any of my live classes. My live class is equivalent to 20 hours of formula-based learning. Most of you know it, but I'll repeat it. I was the ex-South India academic head for Career Launcher. I might have taken session more than 1000 students, minimum 500 times. You will understand why thousands of students sit in my class as and when I start problem solving. You should mandatorily sit with the notebook and a pen or a pencil. Ensure that every key point, whatever I mention, kindly make a note of that important key point in your notebook. These are some of my expectations towards all the viewers who are watching these live classes. Now, I'm sure most of you know it. We stand number 1 in Google reviews all over India. If you type Anil Nair classes, Bangalore reviews, if you type it, Anil Nair classes, Bangalore reviews, you will come to know how students talk a lot about us. 3,643 students gave us a rating of 4.8 out of 5. Why this many students gave? As and when the problem starts, you will come to know. Next, straight away, let us get into the problem solving. Extremely fun-loving class, sir. I will repeat some important key points, then I will solve the problem. Perfect squares. What are the important key points that we discussed? A perfect square is any natural number if the power is an even number. If you take the power as an even number or 0, then that number is called the perfect square. Then the number is called the perfect square. Any power of a natural number, if it is even number or 0, then the number is called a perfect square. Or in simple language, a number multiplied by itself. If a number is multiplied by itself, then the number is called a perfect square. If a number is multiplied by itself, then the number is called a perfect square. A perfect square, important key points, again I am going to use it. It never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. A perfect square unit digit will never be 2, 3, 7 or 8. You take a natural number, if the unit digit of a natural number is 2, 3, 7 or 8, then definitely then the number is not a perfect square. Next one, a perfect square digital sum will always be, a perfect square digital sum will always be, a perfect square digital sum will always be 1, 4, 7 or 9. 1, 4, 7 or 9. If a number is a perfect square, then the digital sum of that perfect square will always be 1, 4, 7 or 9. Reverse may or may not be true. What do you mean by reverse? You take a number, if the digital sum of that number is 1, 4, 7 or 9, it may or may not be a perfect square. But if you take a number, digital sum is other than 1, 4, 7 or 9, then definitely it is not a perfect square. Important key point. Third important key point, a perfect square will always be of the form 4k or 4k plus 1. 4k or 4k plus 1. It can also be of the form 3k or 3k plus 1. Any perfect square will be of this form 4k or 4k plus 1. Reverse may or may not be true. If a number is a perfect square, it will always be of the form 4k or 4k plus 1. If a number is of the form 3k or 3k plus 1, it may or may not be a perfect square. If this is true, this should be true. If this is true, this may or may not be true. I hope it is clear. Let us take some solved examples, then we'll go to our practice problems. These are some important key points with respect to a perfect square. I am going to use all these key points in my problems. A perfect square means a number multiplied by itself. A perfect square unit digit can never be 2, 3, 7 or 8. A perfect square digital sum will always be 1, 4, 7 or 9. If a number is a perfect square, it will always be of the form 4k or 4k plus 1, 3k or 3k plus 1. One example. Solved examples. Then we'll go to our practice problems. Solved examples. First example is 1378. Is 1378 a perfect square? Is 1378 a perfect square? Method 1, answer is it is not a perfect square because it is ending with 8. Any perfect square never ends with 2, 3, 7 or 8. This is one way to solve. Second way to solve, method 2. The last 2 digits of a number is 78. 78 is nothing but 4 into 19 plus 2. Any perfect square will never be of the form 4k plus 2. So it is not a perfect square. It is not a perfect square. Are you all with me? Any perfect square will never be of the form 4k plus 2. Another example. 9324 a perfect square. Is 9324 a perfect square? Is 9324 a perfect square? Now listen carefully. Any perfect square, listen to every problem, sir. Any perfect square is of the form either 3k or 3k plus 1. When this concept is used, now see here, it is ending with, now what you do is, you take it here as 9324. A perfect square will always be of the form 3k or 3k plus 1. Right? If it is of the form 3k or 3k plus 1, it may or may not be perfect square. That is what I wanted to tell you. 9 plus 3, 12. 12 plus 2, 14. 14 plus 4, 18. 18 is nothing of the form 3 into 6. So it is of the form 3k. Here, a perfect square will be of the form 4k or 4k plus 1. 24 is 4 into 6. Next one, any perfect square digital sum. Now if you see, is always 1, 4, 7 or 9. 9 plus 3, 12. 12 plus 2, 14. 14 plus 1, 4, 18. Digital sum is again 1. So it is the converse of all these three things. All are getting satisfied. In the previous question, directly you can say that it is not a perfect square, but in this question all are getting satisfied. In such a cases, what you will do is 9324. Now if you see, we have to check whether the 9324 will give you a natural number or a dot value. Start from rightmost. Keep a slash after 2 digits. If you keep a slash after 2 digits, how many groups of 2 are there? 2 digits are there. Answer will be 2 digits. Now see here. 93. 93 lies between which all numbers? 9 square is 81, 10 square is 100. So that means it is around 90 plus something. 90 square is 8100. 90 square is 8100. 95 square is 9025. Are you all with me? 96 square is 9216. 93 square is 96 square is 80. 97 square we will do. 97 square is how much it is? 9409. Now if you observe, 9324 lies between 9216 and 9409. So it is not 96, not 97, it is between 96 to 97. That means it is not a perfect square. That means it is not a perfect square. I hope the idea is clear. Again I am explaining, not always all the numbers can be directly found out by using perfect square never ends with 2, 3, 7 or 8. A perfect square digital sum is 1, 4, 7 or 9. A perfect square will always be of the form 3k or 3k plus 1, 4k or 4k plus 1. The second is a very good example where all are getting failed. In such a cases, what to do it? You take the square root of 9324, start from rightmost, keep a slash after 2 digits. 93 lies between 9 square 81, 10 square 100. That means it is 90 plus something. 95 square is 9025. 96 square is 9216. How to find the square of a number so easily? There is a logic. Please type how to find the square of a number by Anil Nair. You will find it out. A square minus b square is a minus b into a plus b. So that means a square will become a minus b into a plus b square. This is the logic which I use it to find the square of a number very fast. Suppose if it is 96 square, a is 96. 96 is nearer to 100. Difference is nothing but 4. So answer is 96 minus 4 into 96 plus 4 plus 4 square. Answer is 9216. B is nothing but the difference between the number and the power of 10. B is nothing but the difference between the number and power of 10. That's how I got 96 square as 9216. 97 square will become 97 minus 3, 97 plus 3 square, which is 9409. 9324 lies between 9216 and 9409. Therefore, it is not a perfect square. First is a very easy question. Second is, if all the conditions are satisfied, how to check whether the number is a perfect square or not. It is not that just you execute it, you will come to know, right? What is important in my classes is why, what, when and how the concepts are being utilized. I hope the second example is very clear. I used a square minus b square logic to find out the square of a number. I realized that 9324 is greater than 96, less than 97. So answer is it is not a perfect square. Idea clear? Now I will go to the questions created by me. Third question. Now see here. X square plus 4y square is nothing but 1378. X and y are natural numbers. X and y are natural numbers. How many values x comma y will take? X square plus 4y square equivalent to 1378. X and y are natural numbers. How many values x comma y will take? Now, Anil Nair classes A and C way of solving the question. Listen carefully, sir. X square plus 4y square equivalent to 1378. Any number multiplied by 4, that means it is divisible by 4. 4y square, it is nothing but a multiple of 4. Any perfect square is of the form. So it is 4 into sum instead of x. I will take it 4 into k. Any perfect square is of the form, right? Either divisible by 4 or gives a remainder 1. or gives a remainder 1. I hope it is clear. Any number multiplied by 4, it is nothing but a multiple of 4, so it is 4k. Any perfect square is of the form either divisible by 4 or it gives a remainder 1. If you add two numbers which are divisible by 4, answer will be a divisible by 4. If you see 4y square is divisible by 4, any number which is divisible by 4 is a multiple of 4. Any perfect square is of the form 4p or 4p plus 1. If you add two numbers which are divisible by 4, answer will be divisible by 4. This gives a remainder 1. So 4p plus 4k, that means it is divisible by 4. It gives a remainder 1. Right hand side should be of the form 4 into some number or 4 into some number plus 1. I hope it is clear. 4p plus 4k divisible by 4. 4p plus 1 plus 4k gives a remainder 1. But 78 is nothing but 4 into 19 plus 2. So answer is no solution for x and y. Extremely easy question. If you know this concept that a perfect square is always of the form 4 into something or 4 into something plus 1. The idea behind the question is 4y square. Any number multiplied by 4, it is divisible by 4. This only gives of the form 4 into something or 4 into something plus 1. 4p plus 4k is divisible by 4. 4p plus 1 plus 4k, it gives a remainder 1. Answer right hand side when divided by 4, it should give a remainder 1. But 78 is giving a remainder 2. Are you all with me? Extremely easy question if you know the logic. Now directly you can say this question. Please solve this question. X square plus 4y square equivalent to 9876 543210. Most of the students, those who are not attending my live classes, they will realize that this question is extremely difficult because they don't know how to solve the question. These is divisible by 4. This is something 4p or 4p plus 1. Divisible by 4 plus divisible by 4. 4p plus 1 when divided by 4, remainder 1. 10 when divided by 4, it is nothing but remainder 2. Remainder 2. So answer is, what is the answer? No solution for x and y. Extremely easy if you know the class or if you have attended my class. Other students, they will find it very difficult. They will leave this question, right? They will leave saying that the paper is tough. What is tough for my non-enrolled student will become a very easy question for my enrolled student. Third question. X square plus 3y square equivalent to 1, 2, 3, 2. X comma y are natural numbers. How many values x comma y will take? How many values x comma y will take? These is divisible by 3. Any number when divided by 3, either it gives a perfectly divisible or it gives a remainder 1. Are you all with me? So, but here, what is the divisibility rule of 3? Sum of the digits should be divisible by 3. 1 plus 2, 3. 3 cancel. So, what is the remainder? It is giving 3 into something plus 2, which is not matching. So, what is the answer? No solution for x and y. Very, very easy concepts if you know it. No solution for x comma y values. Are you all with me? You can do this question. You can create. That is how I create a lot of questions. 4x square minus y square. 4x square minus y square. 1373. X and y are natural numbers. How many values x comma y can take? 4x square minus y square is 1373. X comma y are natural numbers. How many values x comma y will take? 4x square. Any number divided by 4, it is divisible by 4. Minus of any perfect square is of the form either 4x or 4x plus 1. Are you all with me? When you subtract two numbers divisible by 4, answer will be divisible by 4. 4p minus 4x. 4p minus 4x divisible by 4. Remainder is 1. So 4 into w minus 1. So answer should be of the form either when divided by 4, it should be perfectly divisible or it gives a remainder minus 1. What is the divisibility rule of 4? Last two digits should be divisible by 4. 73 is 4 into 18 plus 1. I want minus 1. I want minus 1. So answer is no value for x comma y exists. No value for x comma y exists. Are you all with me? No value is possible because the right hand side should be of the form 4w minus 1. That means when you divide a number by 4, negative remainder minus 1 means positive remainder will be 3. For example, suppose 15 divided by 4. 4 3s are 12. Negative remainder minus 1. Positive remainder will be 3. Positive remainder will be 3. Negative remainder minus 1 means positive remainder 3. In this question, nothing I did it. There is no algebra here. There is a simple definition of perfect square I used in this question. 4x square. Any number multiplied by 4, it will be divisible by 4. Perfect square. Any perfect square is of the form 4x or 4x plus 1. 15 when divided by 4. 4 4s are 16, negative remainder minus 1. If you got a negative remainder minus 1, positive remainder is nothing but 3. So in this question, if the negative remainder is minus 1, right, positive remainder should be 3. That means in this question, right hand side when divided by 4, means last two digits should be divided by 4, remainder should give you 3, but 73 when divided by 4, remainder it gives 1. So answer is no value. I hope the idea is clear. All are based on the definition of a perfect square. One more question. If you see the equation, 3x square minus y square equivalent to 1321, xy are natural numbers. How many values xy will take? Again, a very simple understanding of perfect square definition you will come to know. 3x square, any number multiplied by 3, it is 3p. Y square, it is a perfect square. Any perfect square is of the form when divided by 3, remainder 0 or remainder 1. So, if you subtract two numbers, it is divisible by 3. So, this will give a remainder minus 1. When you divide a number by 3 and the negative remainder is minus 1, positive remainder will be 2. Negative remainder minus 1, positive remainder will be 2. Let us check the remainder when you divide a number by 3. Divisibility rule of 3 is sum of the digits should be divisible by 3. Remainder is 1. But I got 2. So answer for this question is no solution for x comma y. I hope you are understanding the concept. No solution for x comma y exists. All the questions are based on the concept. A perfect square will always be of the form either 4 into something or 4 into something plus 1, or when divided by 3 remainder 0, or when divided by 3 remainder 1. One more question we will solve. Suppose if the question is like this, x square plus y square equivalent to 3479. X comma y are natural numbers. How many values x comma y can take such that it satisfies the equation? It is a perfect square. Any perfect square is of the form when divided by 4 remainder 0, or when divided by 4 remainder 1. This is the form of x square. It is also a perfect square. Any perfect square will be of the form when divided by 4 remainder 0 or remainder 1 plus. You take all the combinations. If I add these two numbers are divisible by 3. 4, answer will be divided by 4. This gives a remainder 1. This gives a remainder 1. This gives a remainder 2. That means when you divide a number by 4, in these cases, either 0 we got, 1 we got, or 2 we got. 0 is in this case, 1 is in this case, 2 is in this case. These are the possible reminders. These are the possible reminders. But according to the right hand side, 79. 79 when divided by 4. 4 19s are 76. What is the remainder? 3. Remainder 0, 1, 2 are only possible. So no solution for x comma y exists. No solution for x comma y exists. I hope the idea is clear. I hope the idea is clear. Idea clear, right? This question can also be solved in another variety. This is method 1. I hope the method 1 idea is very clear. Simple usage of definition of a perfect square, you will get this logic. Definition of perfect square. Any perfect square is either divisible by 4 or remainder 1. When divided by 4, remainder 0, remainder 1. Possible reminders are 0, 1, 2. But I require remainder 3. Next, one more question. Same thing method 2 we will do. X square plus y square equivalent to 3, 4, 7, 9. X comma y are natural numbers. How many values x comma y will take? X square plus y square equivalent to 3, 4, 7, 9. Now see method 2. Method 2 is also a very easy type. Method 2. X square plus y square equivalent to 3, 4, 7, 9. Unit digit of this number is 9. If it is 9, 0 plus 9, 9, 1 plus 8, 9, 2 plus 7, 9, 3 plus 6, 9, 4 plus 5, 9. 4 plus 5 unit digit 9. Remaining all are the reverse of these cases. 5 plus 4, 9, 6 plus 3, 9, 7 plus 2, 9, 8 plus 1, 9, 9 plus 0, 9. Are you all with me? X square and y square are perfect squares. A perfect squares never end with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. All these cases are not possible. Any perfect square ends with even number of zeros. Perfect square ending with 9 tens place is even. Any perfect square ending with 4 tens place is even. Any perfect square ending with 5 tens place is 2. Even plus 2, it is an even number. That means tens place should be an even number. 0 plus even, it is an even number. So, tens place should be an even number. Tens place according to the unit digit logic should be an even number. But according to the question, tens place is an odd number. Answer is no value for x comma y exists. Answer is no value for x comma y exists. I hope the idea is very clear. X square plus y square equivalent to 3, 4, 7, 9. Right hand side unit digit is 9. So I played with the unit digit in the left hand side. 0 plus 9, 9. 1 plus 8, 9. 2 plus 7, 9. 3 plus 6, 9. 4 plus 5, 9. Any perfect square ending with 9 tens place even. Perfect square ends with 0, 0. So it cannot end with 8, 2, 3 or 7. 4 plus 5 is 9. Even plus even is even. 0 plus even is even. Tens place should be even. But according to the question, tens place is odd. Therefore, no value for x comma y exists. Idea clear, right? One more question. Each and every question concentrates on a lot of ideas. X square plus y square equivalent to 1544. X comma y are natural numbers. X comma y are natural numbers. How many values x comma y satisfies the equation? X square plus y square equivalent to 1544. Now see the solution. Very easy way to solve the solution if you understand the approach. Now see the question. Each and every question, whatever we are solving right now, ensure that you solve it right after the end of the class also once again. Most of the problems or most of the concepts you will not find in any of the YouTube channels. You can sit and do aram se all these questions research in Google. Everybody will solve the standard textbook problems right now. In this class I create questions. That is the difference. X square plus y square equivalent to 1544. Now see here, the unit digit in this question is 4. 0 plus 4 is 4. 1 plus 3 is 4. 2 plus 2 is 4. 4 plus 0 is 4. 5 plus 9 is 4. 6 plus 8 is 4. 7 plus 7 is also 14. 4. Are you all with me? Right? 6 plus 8 is also. All the cases which we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All the digits we got. X square and y square are perfect square. A perfect square can never end with 2, 3, 7 or 8. These cancelled, these cancelled, these cancelled, these cancelled. Any perfect square ending with 0, tens place should also be 0. Here I require 4 at the end. So this has to be 4. So what is the smallest number that will end with 44? Y square ends with 44. That means y value is 12. Are you all with me? Y value is 12. Y value is 12. So if y value is 12, which are all the logics that I will get? Y square 50 is complement 50 plus y whole square or 50 minus y whole square will give same last two digits. Will give same last two digits. 50 plus y square, 50 minus y square should give same last two digits. 12 square. 50 plus 12, 62 square. 50 minus 12, 38 square. These anyway greater than 1544, right? Now if I take 144, this will become 144, this will become 1400. X square cannot be 1400. So the case that is not possible is 12 and 62. If I case that is not possible is 12 and 62, the case that is possible is 38 square. So 38 square is nothing but 1444 plus 100. So x is 38, y is 10. This is one solution. X 38, 110, this will satisfy the solution. 5 and 9. Any perfect square ending with 9 tens place is even. 7 square 49, 13 square 169. Any perfect square ending with 5 tens place is 2. 9 plus 5, 14, 1 carried. 2 plus even is even. 1 plus even is odd. But according to the question, tens place should be even. So this case is eliminated. So the only case that will satisfy this question is x is 38, y is 10. Extremely high level conceptual questions. Generally in every textbook, a statement will be written. From that statement, I will create so many questions. A student will understand the importance of the statement that is given. X square plus y square equivalent to 1544. The root cause is right hand side unit digit is 4. 0 plus 4, 1 plus 3, 2 plus 2, 3 plus 1, 4 plus 0, 5 plus 9, 6 plus 8, 7 plus 7. A perfect square can never end with 7, can never end with 2, can never end with 8, so can never end with 3. All these cases are eliminated. The only case that is possible is 0, 4 and 5, 9. 5 and 9 is not possible because any perfect square ending with 5 tens place has to be 2. 5 square 25, 15 square 225, 25 square 625, 35 square 1225. Any perfect square ending with 9 tens place is even. 9 plus 5, 14, 1 carried. 1 plus even is odd, but according to the question, tens place should be an even number. So the case that is possible is, right, 0 and 4. Last two digits are 44. Y square ends with 44. What is the smallest natural number? Y that will end with 44. Y value 12. 12 square 50 plus 12 square 50 minus 12 square. 50 minus 12 square is 38 square. 38 square is 1444. Remaining x square 100. So x value will be 10. Please put a star mark on this question. Revisit this question after the class is over. All the questions are based on perfect squares. Perfect squares. I hope it is clear, right? Idea clear? All the questions are based on a perfect square logic. I am sure the solved problems are very clear to you. Now let us go to practice problems. Now see the first question. All are very good questions. How many numbers are of the form 1, 1, 1, 1, 1, 1, 1, 1, 1 and so on are perfect squares? You can solve the problem in two methods. Method 1. All are ending with 1. What is the nature of a perfect square ending with 1? 9 square 81, 11 square 121, 19 square 361, 21 square 441. Any perfect square ending with 1. Tens place should be an even number. Tens place should be an even number. According to the question, tens place is an odd number. Answer is 0 numbers are perfect squares. There is no number except perfect square from the series double 1, triple 1 and so on. So answer is only one number. Answer is 1. These 0 numbers from here, none of the numbers are perfect squares because any perfect square ending with 1, tens place should be an even number. For 11, tens place is an odd number. 111, tens place is an odd number. 11, 111 and so on. All these are eliminated. Only number which is a perfect square is 1. I hope the idea is clear. Method 1. Method 2. Method 2. Any perfect square is of the form. Any perfect square will be of the form either 4 into something or 4 into something plus 1. Every perfect square should be of the form 4p plus 1. Suppose if I take from 11, 111, 4 ones, you take from all this case What are the last two digits of that number? Last two digits of a number is 11. 11 is nothing but 4 into 2 plus 3. 4k plus 3 does not arise for perfect square. Answer for this question is 1. I hope the logic is extremely clear to you. Either you can go by the tens digit unit digit logic, or you can go by the perfect square form. A perfect square is always of the form 4 into something or 4 into something plus 1. Method 1, method 2. Depending upon your observation, you can take any that thing that is possible. Next one, how many numbers are of the form 1, 1, 2, 3, 1 and so on up to the last number is 1, 2, 3, 4, 5, 6, 7, 8. How many numbers in this series? 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. These 1, next is 1, 2, next is 1, 2, 3, next is 1, 2, 3, 4, next is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. Multiple logics we will use. What is the first logic? A perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. All these four cases are out. Any perfect square ending with 4, tens place should be an even number. 8 square 64, 12 square 144, 18 square 324. Tens place is an odd number. Any perfect square ending with 5, tens place is always 2. 5 square 25, 15 square 225. Any perfect square ending with 6. Any perfect square ending with 6. 1, 2, 3, 4, 5, 6. Now 1, 2, 3, 4, 5, 6. We have to check whether this number is a perfect square or not. Now see here. 1, 2, 3, 4, 5, 6. Now if you observe this question, it is ending with 6. So 56 is also divisible by 4. Digital sum also 6 plus 3, 9, 5 plus 4, 9, 2 plus 1, 3. So perfect, it is giving you digital sum how much? Digital sum 3. What is the perfect square logic? A perfect square digital sum should always be, a perfect square digital sum is always 1, 4, 7 or 9. But according to the question, what is the digital sum we got? 3. So these cancelled. So the only number which is a perfect square is nothing but 1. Very simple example which explains multiple concepts. A perfect square never ends with 2, 3, 7 or 8. Depending upon the unit digit, tens place will be there. Already we discussed one beautiful logic. A perfect square tens place is odd number only when the unit digit is 6. Only when the unit digit is 6, tens place is an odd number. This logic I used. A perfect square digital sum is 1, 4, 7 or 9. I hope second problem is also clear to you. Third one. Another one. How many numbers are of the form 4, 44, 444 and so on? Suppose if I take 4 common, these are nothing but 1, 11, 111, these are nothing but and so on. All this. In this one, all these numbers starting from the second number are of the form 4p plus 3. A perfect square will never be of the form 4p plus 3. So answer is only one number and the number is nothing but the first number. Answer is 4. I hope the logic is clear. A perfect square will never be of the form. A perfect square will never be of the form 4p plus 2 or 4p plus 3. Each and every question are created out of a lot of research and to make a student absolutely understand the beauty of this concept. If you miss any of these classes, right, show whatever I am sharing these logics with your friend, probably in your coaching center, in your, right, any of the online classes, this concept is not taught. Most of the concepts that are taught are nothing but the problems taken from the books, right, and most are rote based learning. I hope it is clear. Next one. How many 5-digit perfect squares that can be formed using the digits 1, 2, 3, 4, 5? There are 5 digits. 1, 2, 3, 4, 5. Each digit is used exactly once. Each digit is used exactly once means repetition of digits is not allowed. Repetition of digits is not allowed. When you are using 5 digits in a 5 digit number exactly once, that means repetition of digits is not allowed. Repetition of digits is allowed, not allowed. So one number could be of the form 1 2 3 4 5. Next number could be of the form 2 5 4 3 1. Next number could be of the form 5 4 1 2 3 and so on. Are you all with me? 1 2 3 4 5 2 5 4 3 1 5 4 1 2 3 and so on. Now if you see the digital sum of these number, digital sum of these number is nothing but even in whatever the order that you do it, digital sum will not change. So summation 5, summation 5, summation 5 is nothing but 1 plus 2 plus 3 plus 4 plus 5, summation 15. 15 is nothing but digital sum 6, digital sum 6. So all the 120 numbers that are formed, what are the 120 numbers? 5 numbers arranged in 5 places, it is 5 factorial, which is 120. All the 120 digit numbers, irrespective of the order in which the digits are written, sum of the digits is always 6. A perfect square digital sum will be 1 4 7 or 9. So answer for the question is 0. Answer for this question is 0. I hope the idea is clear. Sum of the digits is 15. 15 is 6. For a number to be a perfect square, its digital sum should be 1, 4, 7 or 9. Idea clear? Now another question. How many 3-digit numbers ABC will satisfy the condition ABC equivalent to A cube plus B cube plus C cube? This is nothing but an Armstrong number. This is nothing but an Armstrong number, one of the very few numbers where you started doing your initial numbers. There are, right, 153 is one such Armstrong number, 307 is one such Armstrong number, 317 is another Armstrong number, 407 is another Armstrong number. If you see, these are nothing but 1 cube plus 5 cube plus 3 cube. 125 plus 27, 152 plus 1, 153. 3 cube plus 0 cube plus 7 cube. 343 plus 27 is 370. Sorry. 371. 371. I wrote a mistake here. It is 371. It is 371. 370. Next is 371. 3 cube plus 7 cube plus 1 cube. This is also nothing but 4 cube plus 0 cube plus 7 cube. 343 plus 64, which is nothing but 407. In a 2-digit numbers, there are 4 such Armstrong numbers: 153, 370, 371 and 407. Like that, in a 5-digit number, 6-digit number, there are some numbers 655053. Like that, there are so many Armstrong numbers that are there. Now these are the 4 such numbers which will satisfy. Instead of doing 4 different values, I will show you how 153 is obtained for one such value. Same process you can find it out. You will get 370, 371, 407 also. Now proof. Why 153 is coming out to be 1 cube plus 5 cube plus 3 cube. I will prove this. So that the same pattern can also be followed by 370, 371 and 407. Now see here, ABC is a 3-digit number. If ABC is a 3-digit number, C is there in units place, B is there in tens place, A is there in hundreds place. A plus 10B plus C equivalent to A cube plus B cube plus C cube. Let me take A value 1. If I take A value 1, 100 plus 10B plus C equivalent to 1 plus B cube plus C cube. So this is nothing but B cube plus C cube equivalent to 99 plus 10B plus C. I hope this equation is clear. B cube plus C cube is 99 plus 10B plus C. Now B cube plus C cube minimum value. b cube plus c cube minimum value will be when b is 0 and c is 0, that is 99. b cube plus c cube maximum value is when b equivalent to 9, c equivalent to 9, which is 198. 198. Listen carefully, sir. b cube plus c cube minimum value is when b is 0, c is 0. b cube plus c cube should start from 99, should end at 99, because the maximum digit b and c can take is when. From this equation, I can say that b and c will definitely be less than 6. Because if I take 6 cube plus something, 216 plus something cannot be 198. B value cannot be 6. So let me take B value 5. If I take B value 5, what will be the equation will become? So this will become 5 cube plus 6c cube equivalent to 99 plus 50 plus c. C cube minus c is nothing but 99 plus 50, 149, 149 minus 25, 24. So these is nothing but c into c square minus 1 is c into c minus 1 into c plus 1 is 24. C is 3. Because 3 into 2 into 4 is 24. A value 1 we got, B value 5 we got, C value 3 we got. So the number is nothing but 153. Are you all with me? Similarly, try it out for A value 2. Similarly, try it out for A value 3. Like that, you will get cases. There are 4 different values, means there are 4 different equations that you have to do it. You only thing you have to do it is for A value 1, 2, 3, 4 and 5, you have to do it. I hope this equation is clear. There are 4 numbers that will satisfy, which are called as an Armstrong number: 153, 370, 371 and 470. These are the 4 Armstrong numbers which will satisfy this property ABC equivalent to A cube plus B cube plus C cube. Very, very good question. One of the first few C programs which you will write when you enter into the first year of engineering. Next one, another good question. Find the smallest positive integer. I want the smallest positive integer. N greater than or equivalent to 2. 2 square minus 1. 2 square minus 1 is nothing but 2 minus 1 into 2 plus 1, which is nothing but 1 into 3. 3 square minus 1. 3 square minus 1 is nothing but 3 minus 1 into 3 plus 1, which is again nothing but 2 into 4. 4 square minus 1. 4 square minus 1 is nothing but 4 minus 1 into 4 plus 1, which is 3 into 5. Next one, 5 square minus 1. 5 square minus 1 is nothing but 5 minus 1 into 5 plus 1, which is nothing but 4 into 6. That means if you observe, 3 is becoming 3 square, 4 is becoming 5, 4 square, 5 will become 5 square. So n square minus 1, which is nothing but n minus 1 into n plus 1. If n is there, previous number will become n minus 1 square minus 1. So which is n minus 2 and n. So all the numbers, if you observe, all the numbers, first 2 are remaining and last 2 will be remaining. N minus 2 into n. So the last it will be n minus 1 into n. Remaining all will have a squares. 3 into 3 is 3 square, 4 into 4 is 4 square, 5 into 5 is 5 square, like that. So what will be remaining is 1 into 2 into 3 into 3, 3 square, 4 into 4, 4 square, 5 into 5, 5 square. First 2 and last 2. First 2, n minus 1, n plus 1. N minus 1, n plus 1. First 2 and the last 2 will be remaining. This 2 and this 2 will be remaining. So n into n plus 1, this is nothing but a perfect square, which is k square. So 2n into n plus 1 into all these 3 square, 4 square, 5 square and so on, that is nothing but another perfect square equivalent to k square. This is a perfect square, this is a perfect square. So this should be a perfect square. For it to be a perfect square, already 1, 2 is there. So extra 2 if I keep 2 into 2 into 3, which is not a perfect square. So 1, 2 is there. Power of 2 should be an even number to get a perfect square. If I take 2 cube, so this is nothing but 2 into 8 into 9. 72 2s are 144. 144 is a perfect square. So the value, smallest value that will make this term perfect square is n is 8. It is a simple calculation problem. 1 into 3, 2 into 4, 3 into 5. If you observe, 3 into 3, 3 square, 4 into 4, 4 square, 5 into 5, 5 square, and so on. So only the first two and the last two will be there. Only the first two and the last two will be there. See, simple thing what you can do is, you take for 3 numbers, you will understand why the first and last are only there. If you observe, first two and the last two. 3 into 3, 3 square, 4 is also a perfect square. You can take smaller values and check it out how many different values are there. It's a very good question. Most of the questions are relatively new question. Please practice good conceptual content. Practice less number of problems but variety of problems rather than practicing one variety of problems 100 times. I hope it is clear.